recently, my family's moved in downstairs to our grandparents, and the downstairs place that we're actually moving to has a really sick microwave that's already embedded into the house, which means we don't need our old microwave with dysfunctional number buttons. So I was thinking, let's take the little bugger apart and then take the transformer out and make a high current death machine. Good disclaimer, this video is not going to be one of those 20-minute videos where literally the whole thing is sawing and chipping off the secondary coil. We are not doing that. Basically, what we're going to do is we're going to take the transformer out of the microwave, saw off the secondary coil, and replace it with a 4 or 3 turn 4-gauge wire secondary coil. This will be meant to output an extremely low voltage, but an extremely high current. Roughly 4 volts at 250 amps. Which is insane. I mean, the voltage is really low, so good thing is it can't push current through you, but 250 amps will burn the crap out of you. So be in the right mind when you do this project. Now, since I'm still only 15 and it's kind of hard to convince my mom to let me do these projects anyhow, I'm going to do this one with Jim. That way I could put my mom to reassurance that I have parental supervision and I have a super good time working on a project with Jim. Plus, it's been a while. We need to get back together. So late afternoon on September 25th, I went over to his place and started taking apart the microwave.
Just make sure you're dead.
Got it. Let me get some dikes. I saw some in your drawer. Maybe I have. Holy sheeskis.
Yep.
Wow, these unremovable bolts are doing fantastic at keeping me from getting in. Yeah, there we go. There, little tabs for mains voltage, heater element, and output. So we got our transformer, but then we ran into a little bit of a problem.
So we're just cutting through.
Yeah, just cut that piece off right now.
Yeah, it had a mounting plate. Lucky for me, Jim and his family are really good with tools, and they have some really nifty ones. Oh man, that came off real fast.
Yeah, that's the best way to do it.
Holy crap.
It's alright. It's okay.
We'll remember this day forever. Well, wasn't me. Like half of it did.
This solves all the matters.
Oh, you good? So we sawed off one end of the secondary coil, but there was still a whole other maybe 3/4 or 5/6 of it left stuck into the iron core. So we have to do the old hammer away, 3 taps on each side, take turns method. So we backed the car out of his garage and put it in the vise. Awesome, it's coming out. My goodness, we had to put it in really tight. So tight that you could see the vise imprint marks on the transformer's iron core, which is insane because this is not exactly the softest metal. Now, after what had probably been at least 30 to 45 minutes of hammering and trying to get the stake out of the dang holes and loosening it and readjusting and then tightening it again and then hammering and then doing it all over again, we finally got the dang thing out. And seriously, if you're going to do this project, there's no way you're going to salvage the wire. It's the sad truth, but you just gotta beat the crap out of it to get that thing out. And beating the crap out of that coil also means you gotta beat the crap out of yourself. Because by the time we were both done hammering the secondary coil out of the transformer, both me and Jim were blood red. So he took a bit of a pizza break and then took it down to his lab. Now, time for the fun stuff. We put some electrical tape around the core, and then we were able to start winding the secondary coil out of a thick 4-gauge wire. Now, it's important that the secondary coil is made out of stranded 4-gauge wire. Me and Jim began to think that we'd only be able to fit 2 turns on this thing, and 2 turns is too little for 4-gauge wire. That's 500 amps. 500. So again, I emphasize the importance on this. Fit at least 3 turns of 4-gauge wire on your transformer. No lower. So it took a lot of, okay, let's undo this and start over, and lubricant to actually get the 3 turns we needed. And we had to have some turns side by side and kind of in an awkward position, but after much pushing and pulling and applying lubricant, we were finally able to get the coil wound. 3 turns. So we went over to the garage and we tried a 3-inch bolt on it. So we plugged it in, and a couple sparks every now and then, but no glowing red. So we thought maybe the 3-inch bolt was a little bit too thick for this application, which it shouldn't have been. So what we did is we grabbed some steel wire, probably about 16, 18 gauge, and we put it in between the 2 wires. So then we plugged it in, and I flipped out.
Yeah, there you go.
What the heck? Oh my goodness, that was awesome.
Right, it draws.
No freaking way.
I got up to 200 and some amps.
Now we had enough of steel wires. Now that we knew our connections were legitimate, we tried something bigger. All right, you lived a good life. Yeah, this bolt had to be at least half of an inch thick. So we clipped this bolt onto the terminals, and this is what happened. Should I keep it on? The MOT started working so hard, it started to vibrate the floor, and I could feel the buzz on my feet. And I was like, should we unplug this? And Jim was like, no, let it keep going. Should I turn it off? So I let it keep going, and then all of a sudden it started rattling, and you could hear it hitting the garage stone floor. And I was like, are you sure we shouldn't unplug it? And he's like, no, keep going. Gosh.
Leave it on. Leave it on. See the metal discoloring?
Yeah. Come on, man. Come on. Yeah. Woo! And then it started moving across the floor. Like, it started shaking and moving its way across the floor, and the insulation was melted, and all the secondary windings are now fused together.
600 amps.
Oh, holy fetch.
All right, turn it off. That's good. It did its thing.
It was moving. It was working really hard. And even more insane, the current went up to 600 amps. That's unreal. If you follow me on Instagram, you were able to see the tips of the wires after that experiment, all melted. Overall, this was a really awesome project. A super simple procedure, even though you gotta work your butt off to get it done, but still, the end result is totally worth it. And that's all for this video. And remember, if it ain't broke, don't fix it. Upgrade it.